Welcome back to the basic Arduino Basic project, and today we will learning about push button controlled LED system. Here is the agenda: push button controlled LED system overview, components, principle and procedure. Overview. So in this lesson we will learn how to detect the state of a button and toggle the state of the LED based on the state of the button. Components. These are the components required. So Arduino Uno USB cable, 220 ohm resistor, 10 kilo ohm resistor, LED, push button, breadboard, several jumper wires. So here USB cable is not required to simulate using the Tinkercad. Next is the button. So buttons are a common component used to control electronic devices. So they are usually used as switches to connect or disconnect the circuit. So button is the input device. So although buttons are come in variety of sizes and shapes, here you can see the button diagram. So this one. So it works like a switch. When you press it, circuit connects and current flow, and when you release it, circuit disconnect and current stops. Like a doorbell, when you press bell rings, when you release bell stops. In Arduino, button sends high or low signal to the microcontroller. Next is the interrupt. So this is the smart method. There is also one more old method, that is called polling. So imagine you are waiting for your friend to call. Every 1 second you check your phone. That is nothing but polling. So here CPU keeps checking again and again. So waste time and slow response sometimes. But in interrupt, instead of checking phone every second, you wait when call comes, phone rings. So that is interrupt. So here processor does other work. When button is pressed, it stops everything, runs special function. After that returns back. So interrupt saves processor time. So hardware interrupts are introduced as a way to reduce wasting the processor's valuable time in polling loops, waiting for external events. They may be implemented in hardware as a distinct system with control lines, or they may be integrated into memory subsystem. So key functions, one is the attach interrupt, interrupt, ISR, mode. So it is used to connect a pin to a special function that is called ISR, that runs automatically when an interrupt occurs. When a specific event happens on a pin, Arduino immediately runs the ISR function. ISR must be short and fast. So delay and millisecond do not work inside the ISR. Here we are using delay microsecond. So modes are nothing but low means when pin is low, change when pin value changes, rising low to high, falling high to low. So it is used to respond quickly without continuously checking the pin. And next is the digital read. So it is used to read the value of a digital pin. It returns high or low, and it is used to check if button is pressed or not. And delay microsecond. So it is used to pause the program for a very small time in microseconds. 1000 microsecond is equals to 1 millisecond. So it is used for very short and precise delays. For long delays, use delay off like that. And next is the procedure. First we need to build the circuit, then we need to write the program. Let's do this using the Tinkercad simulator. For this, required components is push button, resistors and LED. Login, create circuits. So first you need to search Arduino. Arduino Uno R3, and we also require breadboard. And one LED and push button. Oh sorry, by mistake I have clicked push button. And we also require 2 resistors. One resistor 220 ohm, not kilo ohm, that is for LED, and one more is required for push button, that should be 10 kilo ohm, sorry, 10 kilo ohm. Yeah, now we need to connect this. Let's place. Yeah, now we need to add resistor. We need to connect this to cathode end, then we need to connect it to ground. Yeah, this connection is over. And this positive end should be connected to the pin. Here I will give this to pin number 13. And next is the push button connections. This connection over. Now you need to connect this to pin. So we'll connect this to pin number 3. Let's connect this. Pin number 5. I'll connect this to pin number 5. And this should be connected to the power. So this positive rail is for the power connections, okay. Negative rail is for ground connection. This one, right? Positive rail. Yeah. And we require this resistor. this to pin number 2, and this terminal should be connected to ground. So yeah, I just connect it to ground. So here negative rail is there, right? Just connect it and you need to connect from here also to ground, to the negative rail. Yeah, this one. This connection is over. Now we need to write the code. So first we need to declare pins. So here one is the LED and one is the push button pin, right? So first int LED equals to, LED is connected to the pin number 13, and int button is connected to the pin number 2. Pin number 2, right? Yeah, now we need to write one variable val. So in byte setup we need to declare whether it is input or output. So here LED is the output, and what about button? When you give button, based on button LED works, right? That is input. So next is the equals to equals to digital read of, here you need to write button. And now we are using if else condition. If value equals to high, then what will happen? Digital write of this LED should be low. LED should be low. So here we deleting this delay which is not required. So if value equals to high, then LED should be low, else it is high. So digital LED, it should be high. Yeah, now run simulator. So it should glow now. When you click this button, it should be off. Yeah, it's glowing now. When you click this, it's off. Yeah, you can see. This is push button using push button and LED interface. So this circuit has LED connected to the output pin and a push button connected to input pin. So when button is pressed, input becomes low, right? Here you can see, and this Arduino should be turned off. So similarly, when button is not pressed, it should be high. You can change this logic and observe the output. So that is also possible. So this program controls an LED using a push button. First the required variables are declared, right? So here you can see LED is 13 and button is 2. So in this setup function, LED pin is configured as a input. Sorry, LED is output and the button pin configured as in the input. So Arduino knows how to use them, and in the main loop section the Arduino continuously checks the button status. If the button is pressed, the LED turns off. If the button is not pressed, the LED turns on. So overall the program continuously monitors the button and controls the LED based on its states. So that's all about the push button controlled LED. For more projects, please watch the upcoming videos. Thank you all.